This next question is one that uses a data file q6golf.csv. The question calls it a spreadsheet file, although it is unlikely you'd be using spreadsheet software to do this question. Most likely you'd be using RStudio, or the commercial software Minitab is also a possibility. Some people say you can use Microsoft Excel for these kinds of statistics questions, although in my opinion they're wrong and you're much better using RStudio instead. So it tells us it has data on distance travelled by golf balls, travelled by 40 of one type of golf ball and 40 of a new type of golf ball, and they are different golf balls, and we collect data in meters. So, and it tells us here that the data is normally distributed, and that's important. In part A, part 1, it says generate and state appropriate measures of location and spread. So some people don't know what this means. Location is another word for average. So it will either be the mean or the median. And spread will either be standard deviation or interquartile range. To decide which one you use, that's when you have to look at this normally distributed fact. And if you have normally distributed data, the appropriate summary statistics are the mean and standard deviation. So that's what we need to go and do now. The first thing you must do with RStudio is set the working directory before you can open any files. So here I've RStudio open already. Possibly in your exam you might have had the technicians or the people administering the exam open that up for you, although I understand the people's experience differs in different schools. So once you've opened up RStudio, to set the working directory, you go to Session, Set Working Directory, choose Directory. Then you navigate to the directory that you want to use. The one thing that is confusing for people is if you go to this directory, you can't actually see the files that you want to open. However, once you click on Open, you can see on the bottom left, on the bottom right, under Files, you can see the file is there, q6golf.csv. Now we need to load in the data. So the formula for this is in your formula sheet. It's the read.csv command, and you can call it my data for the variable, although you could use any variable name for that. And don't forget to put in double quotes and match the file name exactly. So this is q6golf.csv. I saw somebody one year just missed that q6 bit out and got confused. So once you've done that, next step is to attach. So attach my data, and this makes all of the data fields in the my data frame available to use. And it's nice just to have a look and click on it and see what the data is, current and new. So if you remember the question, this refers to distances travelled by the current golf balls and the new golf balls. And we have 40 of each. Find the mean and standard deviation. You find the mean with mean, and that is in your data booklet, open bracket, for current and for new. And once you have these answers, you need to copy and paste them, or even just copy them into your answer document. And you can see here you have spaces at the top for your name, Scottish candidate number, and the name of your centre. So that is the distance travelled on average by the current golf ball, and we also do it for the distance travelled by the new golf ball. We also need to do standard deviation, which is with SD, so current and new, and we can put those into the answer document as well. So 9.9, one decimal place. There's no exact rule how you should round these things. Part 2, we need to make two valid comparisons about these driving distances, comparing the current golf balls and the new golf balls. Looking at the means we calculated, we can see the mean is greater for the current golf ball and less for the new golf ball. You have to put that in context, so one way is to use the words on average, and we could say that the new golf balls on average have less distance than the current golf balls, or you could even say the other way around and say the current golf balls have more distance travelled. The distance travelled would be greater. I'm doing it here and putting the new golf balls first, but then saying the distances travelled by the new golf balls are less than the distances travelled by the old golf balls. We also need to make a comparison based on the standard deviation. We can see that the standard deviation for the current golf ball, 8.8, is less than that of the new golf balls, 9.9, so it means that those distances are more consistent. You cannot simply say the standard deviation for the current golf balls is less, because that means you are not showing what standard deviation actually means. So the distances travelled by the new golf balls are, or you could say it either way around. And try and match the exact wording. So I said old, but I really should say current, just to make sure absolutely clear which one I'm referring to. So the current golf balls distances are more consistent. In this comparison of standard deviation, do not use the words on average. The other way around you could word it is you could say that the new golf balls distances are more varied than those of the current golf balls. However, I would just pick one and stick to it. So look for which one is smaller. That set of data is more consistent. Now looking at part B, state the null and alternative hypotheses. So basically, null hypothesis is the absence of any relationship, difference or association. Alternative hypothesis is the presence of such an association, relationship or difference. So in this case it's a difference that we are looking for. So the null hypothesis would be that there is no difference. This is a difference in means, so we should say there is no difference between the mean distance travelled by the current and new golf balls. Alternative hypothesis is just that there is a difference, so copy and paste and change a few words. So now we're going to go on to part C, and we have to look at naming the hypothesis test. Now, there aren't too many types of hypothesis tests that you see in this course. You have really four main ones: t-test for independent samples, a paired t-test, a correlation test, and a z-test for two proportions. Now, the t-tests are the only ones that are used for comparing means, and in this case it's the independent samples test. There's no meaningful pairing between the two data sets, and that paired t-test is often only used for people, and we don't have people here, and it is different golf balls, so definitely not a paired t-test, although we do have 40 of each, which sometimes misleads people that they think it's the same number. So that might be a clue. It's a paired test, but not in this case. So it is the independent two samples t-test. In part C, part 2, we need to carry out this t-test, and the command that you use is t.test, and you list the two variables current and new separated by a comma, and there's no extra argument or parameter given to that. Once you have the output, you then copy and paste the output of your t-test from RStudio into your I meant to say answer document. So highlight, and for some reason I'm having a bit of trouble here highlighting everything. Maybe could have zoomed in too far, but you get there eventually. Zoom there, zoom out makes it easier. Get the whole thing in one go. So right click copy is one way, and then paste. And you have to interpret this, get the p-value of 0.188, and that's just done with part 2. It's the reason that the samples in this question had to be the same size, 40 and 40, is because if they were different sizes, there would be an extra parameter that would need to be added to the t.test function, and that extra parameter is not actually given to you in your data booklet, although it is possible the data booklet changes in the future. This is something to be aware of when doing a project, in case you're using a t-test for a project, and in that case you may need that extra parameter to do it. But there is no reason why in principle an independent samples t-test would not have different sample sizes, for example 35 and 45. There would be absolutely nothing wrong with that. Finally, in part 3, we need to interpret this p-value and interpret it in context. So just running the test in RStudio is not enough. You need to actually make sense of what it means. So you compare the p-value to a standard cutoff value of 0.05. That is the probability, the p-value is the probability of getting such unlikely results. So if a small p-value means you've seen something very unlikely. In this case we only have 18.8%. So this could have happened purely by chance that we get such a difference. That does not mean that no difference exists. It means that we don't have evidence of a difference. So we should make the comparison. The p-value is greater than 0.05, and that means you fail to reject null hypothesis. You have two things you can say. One is you reject the null hypothesis, and the other one is you fail to reject. You might think fail to reject is a bit of a wordy way of saying it, but you should definitely not say except the null hypothesis. There may be a difference, and the null hypothesis may be false. There may be a true difference, but you just don't have the evidence to show it. So that gets you 1 mark. The second mark is for putting this in context and stating it in the terms of the hypotheses. So it's about a difference in means of the distances travelled by the golf balls. So it means we don't have evidence. There's not enough evidence to conclude that there is a significant difference in the means travelled by the mean distances travelled by the golf balls. And I said old again, I meant to say current and new golf balls. You have to have the word significant in there. Now what does a significant difference means? A significant difference means a difference for which you have evidence to conclude it exists. It does not mean a large difference. So in my opinion, the word significant is kind of superfluous here. I'm not sure why you need it, because you have said that there is not evidence to show a difference exists. However, you do need the word significant. It's almost like a ritual which you have to state it's a significant or there is no significant difference. So we'll just finish this off by looking at the SQA marking scheme and seeing what they've required. So you can see again here the word significant, which you should use, and you can see they're referring to the mean. So for full marks, you say you should use both. Here there is no significant difference. Well, a difference in what? You haven't said what the difference is, so you lose the mark for that. I'm not sure what's going on here with this note, but I think it's not too definite. Would mean you don't say there is no difference. There is definitely no difference. It's this point here about there being insufficient evidence of a difference is really what your conclusion is. So I hope you didn't find that too bad. In my experience, people get the hang of RStudio and don't find it too bad once you get the hang of it, even though it may seem quite unusual when you start using it. And in my experience, people often find RStudio in fact easier to use than a spreadsheet. And what you may actually be asked to do with RStudio in an exam, or even using it for your projects, is quite formulaic, and there's not a huge amount of variation in what you may be asked to do. So if you're feeling slightly overwhelmed or confused by RStudio, please don't give up. It just needs a bit more time for you to get used to the various procedures that you may need to carry out using it.